You've built a RAG pipeline. You have a vector database, an embedding model. Everything is connected. You ask it a question and it gives you a confident, well-structured, completely wrong answer. The chunks it retrieved look relevant. It's pulled them from the right PDF, but it's not the right answer. That's not a retrieval problem, that's a ranking problem. The query, heart failure treatment, might pull back chunks about cardiac arrest when you actually needed heart failure management and other similar things. A reranker doesn't replace your vector search, it works after it. You retrieve the top 20 candidates, top 20 chunks similar to your query, and then you hand them one by one to a reranker model that reads the query and the chunks pulled together and asks how relevant is this chunk to the user's query. And the result is a reordered shortlist where rank 1 actually deserves to be rank 1. In this video, we are going to break down exactly how rerankers work and when you should and shouldn't use them in your pipeline. Let's get into it. Alright, the way rerankers work is the user sends a query, best practices for RAG. The query is embedded, sent to the vector database, and then the top k chunks are pulled. In this case, it's 10. You can specify the number of chunks. It could be 12, 15, 25, doesn't matter. Then those chunks plus the user's query are sent to the reranker model, which then spits out the top n chunks. In this case, it's 4. It can be 5, 6, depending on the amount of chunks you want to return from the reranker model. And then these chunks are sent to the LLM, which in turn generates a final response. Now, how this is different from the traditional RAG is, in normal RAG, you get a query, you embed it, pull the top 10, you specify the number of chunks you want, let's say 4, you put the top 4 chunks, and then you send it to this LLM. But in this case, you send your embedded query into the vector database, it pulls the top 10 chunks. Those chunks are then sent to the reranker model along with the user's query, and then the reranker model places both the query and the chunks pulled from the vector database side by side, checks how relevant each chunk is to the query, and then returns the top n chunks. In this case, it's 4. You can specify 5, 6. It doesn't matter. Just specify the number of chunks that you want to be pulled from the vector database, and these chunks are then sent to the LLM, which generates a final response. Let's head over to Any10 and see this in action. Alright, we're in Any10, and the first workflow we're going to use in this example is the regular RAG agent with a chat trigger, the agent node, the LLM, the conversation memory, the vector database node, and the embedding model. While the other workflow is the same agent, but this time with the reranker model, which it's going to use to re-rank the results that we get from our vector database before feeding it to the LLM to generate a response. Alright, so let's test the first one. We're going to send a message. We'll ask, how did Apple's revenue growth in 2024 compare to Nvidia's? It's making the search. Okay, I couldn't find specific information about Apple's revenue growth or I compared to Nvidia. However, I did find a few details about Nvidia's revenue. This increased by 244%. Alright, so we do not get a full response because we are pulling 4 chunks. Yeah, we're pulling the top 4 chunks similar to the user's query from the vector database. Let's see if we get a different response with the Reranker one. So send the same question how did Apple's growth in 2024 compare to Nvidia's? Right. So what the Reranker does, what this agent does rather, is it sends a request. The LLM sends the user's query to the vector database. Then the chunks are pulled, which is then sent off to the Reranker model, which examines the chunks pulled from the vector database and the user's query, and then it calculates a relevant score of each chunk pulled from the vector database to the user's query, and then it sorts them in descending order. So you can see the first chunk it pulled is 0.91 relevance, the other one is 0.90, third one is 0.83, and last one is 0.76. You can specify the number of chunks you want to pull and send to the LLM, and in this case we specified 5. You can set this to 20, 30, depending on how the documents are and the level of accuracy you want to get from your response. So now let's look at the response. In 2024, Apple's revenue grew significantly, reaching 60.9 billion. This is correct, which represented a 126% increase compared to the previous year. On the other hand, Nvidia's revenue also saw. Yeah, so basically this response is correct. We asked how Apple's revenue growth in 2024 compared to Nvidia. So it's expected to look at Apple's revenue in 2024 and Nvidia's revenue and then compare and then generate a response, which it did. So now let's cover when you should not use Rerankers. So if you have a small set of documents, 5 to 10 documents with similar content, a vector search is already precise enough. There is no need for the additional Reranker overhead, because adding a Reranker model means you need to pay. You have some sort of subscription to a Reranker service like over here. Another reason you might not need Rerankers is every Reranker call adds time. So if you're building a real-time application where the agent's response speed is very important, like your users need to get fast responses, the accuracy gain that you get from a Reranker might not be worth the latency overhead that the Reranker adds. And lastly, the last reason you might not need a Reranker model is if your embedding model is already domain specific. So for instance, if you're working on a medical agent and you're using a medical embedding model like embedding Gemma from Google, which has been fine-tuned to the niche of document in your vector database, there is no need to use a Reranker. Thank you for watching this video. Like and subscribe, and see you on the next one. Bye.